All right. In chapter 5, we're still talking about quantitative distributions of data. But we're focusing more about comparing things. So we can look at a histogram, right, and we can find the 5-number summary, and we can talk about the shape, we can talk about the center and the spread, and yada, yada, yada. But we don't know much about outliers. So we assume this would be an outlier, but we're not really sure, right? We can also start talking about if we're comparing things. Like on the free response question on the quiz, you were comparing dot plots, right? They were on top of each other, so you could have the same number line. You could kind of see some similarities and differences. If you're comparing histograms, you have to compare them side by side. So then you just hope they have the same x-axis, so you can compare them pretty straightforward, maybe not. For a stem and leaf plot, you can compare them. If you do a back-to-back plot, you can kind of see how they compare. But all those things take up a lot of space and probably take more time than necessary if you're trying to compare two distributions, all right? So we're going to talk about box plots today because you can construct box plots that take up a lot less space. You can construct them a lot quicker, and you can stack a lot of them on top of each other or next to each other to make direct comparisons. All right, it's a lot easier than having like 5 histograms sitting next to each other that then you really can't line anything up. Okay, so some of you guys have seen box plots before and some of you haven't, so I'm just going to go through how to make a box plot. So on page 81, there are step-by-step directions for future reference. I'll walk you through this one today, but if you need to go back and look at how to make one again, it's on page 81. All right, I'm going to kind of go out of order of the directions today for the first part and then go back to talk about some other things. Okay, so a box plot is based on a 5-number summary. We talked about the 5-number summary last week, right? The 5-number summary is the minimum value, the first quartile, the median, the third quartile, and the maximum value. If you know those 5 numbers, then you can make a box plot. Okay? So here I have agility test scores for the boys in a specific 4th grade class. There's also girls' agility test scores. The whole point of this was to go through and compare the two distributions. But I just want to focus on making a box plot. So we're going to focus on one data set right now. Okay? So in order to make the box plot, like I said, I need the 5-number summary. You can do that by hand if you want to, but I don't have time for that. So I would get the 5-number summary from your calculator. Okay? So I'm pretty sure I already typed these in this morning, maybe. Yeah, I did. But I changed one of them, I think. Yeah, I did. So I would just go to Stat, Calc, one variable statistics, and scroll down here, and I have the 5-number summary. So I know minimum is 17, 18. Q1 was 18. What was the median? I already forgot. 22. Q3 was 23. And the max was 29. Okay. All right. So a box plot is based on some number line. So you have to construct a number line that takes into account your minimum value up to your maximum value. So I need to make a number line that somehow gets me from 17 to 29. I'm going to go ahead and just count by 2s. Okay? So like you're legitimately just drawing a number line. Well, I guess I'm counting by 1s, aren't I? I made my number line plenty long this time. Okay. So we got a number line, no big deal. So remember, when we have quartiles, we're splitting the data into segments that have 25% of the data in each piece, right? So from the minimum value to the first quartile, if we put all the numbers in order, right? Each quartile would have the same amount of data points, and each quartile would have 25% of the data in it, okay? So from the minimum value to the first quartile would be 25% of the data. And then from the quartile 1 to the median would be 25%, and so on and so forth, all right? So it's nice to be able to notice those percentages when we start to compare things. The first thing we're going to do is talk about the middle 50%. So we want to worry about what's in between the quartiles. All right, so this is what we do. We graph a point for each quartile and for the median. We're going to do it above the number line so we can actually see the box and the number line's not going straight through it. Okay, so my first quartile is at 18. My median is at 22. My third quartile is at 23. And I'm going to construct a box out of that. So the box is representing the middle 50% of the data. And then I'm going to split the box through the median. So it's the middle 50%. So each half of this box is 25% of the data. And you can see that one half of the box is like really stretched apart and one half is all close together. So that means that from the first quartile to the median, that 25% is way more spread apart, right, than from the median to the third quartile. Okay, so we can kind of see shape here. We can't see if it's unimodal or anything like that, but I can kind of see how things might be spread apart in different segments, okay? Once I've done that, I need to put in the minimum and the maximum values. So in middle school, they call these box and whisker plots because you have a box and you have two whiskers representing the distance from the quartiles to the minimum and maximum values. So you want to call them box and whiskers, you can. If not, just call them box plot. So put another point at the minimum and maximum. And then we draw our whisker from the box to those points. Again, 25% of the data is in with each of those sections, right? So I can't necessarily say if it's unimodal, but I can say that this distribution looks like it may be skewed to the right, right? There's a super long tail to the right, so it looks like it might be skewed to the right. Sometimes you can tell things are symmetric because the boxes, like the middle of the box, the two halves are about the same, and then the whiskers are about the same. So you can kind of get an idea of shape, but you don't get to see as much as you would with a histogram. So that's one detriment to this. Okay? But I do have a definite measure of center because the median is represented in the box plot. I do have a measure of spread because the IQR is represented in the box plot. Right? So I don't have to like estimate. It's there. Okay? Now here's what box plots are also helpful for. We can start talking about outliers. Does anyone have any questions about how I constructed that box plot before I move on? Okay. So we've said a lot in chapter 4 and stuff that we have possible outliers. And so possible outliers are great and wonderful and all, but we want to know if they actually are outliers or not. So in a box plot, we can start talking about how to find those things. And we have these two formulas, we call them fences. We have an upper fence and a lower fence, and if we draw those in, then we can figure out anything on the outside of those fences would be an outlier. So I'm going to go ahead and find the fences for this data set. The upper fence is the third quartile plus 1.5 times the IQR, and the lower fence is the first quartile minus 1.5 times the IQR. I have seen some AP questions where they give this to you, so you don't have to know it. And I've seen some AP questions where they do not give it to you and you're expected to know it. So because of that, I expect you to know that in this class. I'm not going to give it to you. It's not on a formula sheet anywhere. If they happen to give it to you in the question, you look out. If they don't, you better know what it is. Okay? So, if I'm going to find the upper fence for this data set, I'm going to take the third quartile, 23, and add on 1.5 times the IQR. So the IQR is 23 minus 18, so the IQR is 5 in this data set. To find the lower fence, I'm going to take the first quartile and subtract off the same amount. So they're almost like boundaries, all right, that you're creating. So they need to be above the third quartile and below the first quartile. So if I calculate those, so you get 7.5 plus 23 is 30.5. 18 minus 7.5 is 10.5. All right, I could draw those fences in. So in the book, it's going to suggest that in order the steps in order you would make the box, all right, then you need to go ahead and find the fences and kind of construct them, and then go through the process of doing the whisker part. Because if you have outliers, you don't want to make the whiskers and have to erase them and go back and redo some things. But I wanted to make sure we understood the box plot before we did that today. All right. So in this case, my fences are at 30.5 and 10.5, which is way down here somewhere. So there would be outliers if any point fell outside of these fences. So above 30.5 or below 10.5. None of my data values do. Right? So in this case, I have no outliers. Does that make sense? All right, I'm going to change this data set for the sake of argument so you can see what happens. And I'm going to add in an outlier. Okay? So that I don't have to change any math, I'm just going to change the top number. Okay? If I change the maximum value, then that does not change the IQR, and it doesn't change the quartiles, and so my fences will still be the same. Okay? So I'm going to change 29, which was the maximum number. I'm going to go ahead and change that to 33. All right, so now the maximum is 33. So if we actually had drawn this 33 falls way out here, right? Okay, so now I have issues because now I'm past that fence, right? So 33 is an outlier. So in order to fix our box plot, what we do, we make the outlier special. So you make it a star or make it some symbol like a triangle or something just to say, hey, this is an outlier. So it looks different from everything else. Okay? But then I need to make that whisker still. All right? So that whisker would then stop at the next lowest value. Okay? So 33 is my maximum value, and the next value would be all the way down at 24, it looks like. Right? So I would move that whisker all the way down here to 24. Okay, yes. So now I have a box plot that shows there's an outlier. Right? But an outlier, then I don't want to draw a line all the way from my box to that number because there might be a huge gap in between there. In this case, there is. There's a huge gap in between there, right? So I want to show that, hey, there's a special point over here, and really the rest of my data is all within here. Okay? So now if you're looking at the data set, it looks more symmetric, maybe, because there's that one outlier. Okay? So here are some things to know about outliers and maximums and things. The AP exam will try to get you because they want you to be like, okay, outliers are special and you treat them differently. Well, you do. But if it asks for the range of this data set, the range is still the maximum value minus the minimum value. And the maximum value is still 33. Okay? So even though it's an outlier, it's still the maximum value. Don't get that twisted that it's not the maximum value anymore. Okay? It's still the maximum. All right? So make sure you keep those things straight. The 25%, there's still 25% of the data between the end of the box and the outlier. Right? Because it still counts as a data point. So make sure you realize that too. Okay? That makes a little bit of sense for how we fix things with our outliers. Now here's some good news. We made histograms in our calculators, right? You can make a box plot in your calculator. Okay? So, now this is only if you're given all the numbers in the data set. On the homework tonight, you're not given all the numbers in the data set, you're given the 5-number summary, so then you can put the 5-number summary in because it'll end up having to be the lowest and the quartiles and all that jazz, right? But just be careful. You should be able to draw by hand as well. You know how I said they don't ever make you draw histograms on free response questions, like ever? They make you draw box plots all the time, right? So you got to know how to make a box plot. So go back to if you have data in your calculator, if you have this or not or whatever you have. If you want to put that in, then I can change this. I'm going to do this with 29 first, so I'm not changing my data. You're going to go back to the same place where you did the histogram. So if you recall, that is second y equals stat plot menu. Now there are two different box plots. There's one with dots at the end, there's one without dots at the end. All right, I'm going to do the one without dots at the end first. So if you hit graph, and then you always want to hit zoom 9, that's our new favorite thing. All right, there's our box plot. Now, this is the original data set, so if I go back to stat plot and I change it to the other box plot, there will be no difference. Same exact box plot, okay? Now, the difference then between the two choices. All right, there's a box plot and there's a box plot with outliers. So up here in second stat plot where it has the one with the dots, that's going to be one with outliers. So in order to show you that that actually works, I'm going to go back to my list. I'm going to change that 29 to a 33 again. So now it looks more like what I've got on the screen. On here, you can choose what mark you want the outliers represented by. It really doesn't matter. We'll hit zoom 9 again, and you'll see that there's an outlier out to the side. Okay, so your box plot does do all this for you. Box plot, your calculator does all these box plots for you. You can hit the trace button like we did the histogram. If you hit trace, it tells you the minimum value and the quartile, so it makes sure that that's all you're supposed to have. Notice that it still shows the outlier is the maximum value because it is. And the next lowest value is 24. Okay, so it doesn't change it to maximum and that kind of thing. So you just know it's still the maximum value. All right, so it's all in your calculator. Is that okay? Yeah. So, again, those are good because you can stack them. All right, so remember this question was about a boys' agility test, and there's girls' agility test numbers as well. I can make another box plot. I'm just going to make one up, but I can make another box plot right here, right, and then I can have direct comparison. I see which median is higher, right? I can see how the IQR compares, right? So the boys was, the IQR middle 50% was way more spread apart than the girls. Okay, I can see the minimum values pretty much line up. The maximum value, right, was way out here at the outlier, that kind of thing. But I can see all those things. They're called parallel box plots. You can stack them up. All right, that's what we're going to have to do a lot in this chapter is compare them. So we're going to be doing a lot of stacking of them. Okay, now on your homework assignment, I want to go over some things with you so that everyone's not confused. The first two questions give you 5-number summaries as well as other information about the data set, but they don't give you the data set. So it gives you all those numbers, plus it gives you the mean and the standard deviation. When it says count, that just means how many numbers there were in the data set. Okay? And the first question is going to ask you if you think that the distribution is symmetric or skewed, just by looking at the numbers. If you're going to see something symmetric or skewed, you want to look at the median and the mean values. Okay? If the median and the mean values are close together, then what shape do you think it is? Symmetric or skewed? Symmetric, right? If they're really close together, that means that the mean's not getting pulled in any direction, right? So it should be approximately symmetric. If they're really far apart, then it's probably skewed because the mean's getting affected by some tail that exists. Does that make sense? Other things from the homework, you're going to make a box plot with a 5-number summary. Don't forget that the first quartile and the third quartile are also called percentiles. The 25th percentile is the first quartile. The 75th percentile is the third quartile. It's the same thing. They're still giving you the same information that you need. And if it's asking you to describe the distribution, you're still doing shape, center, and spread. Now your shape is going to be less involved. You can't say unimodal and that kind of thing. So you can say it looks like it's skewed or it looks like it's symmetric just based on the segments of the box plot, right? You have a measure of center because you have the median. You have a measure of spread because you have the IQR, okay? So you can talk about those things in context, preferably, right? So for the homework, that's what you're going to be doing a lot of. You're going to be constructing box plots from 5 number summaries and comparing. All right, so the first 2 is like one box plot, and then the other 2 you have to do multiple. So it'll give you the 5 number summaries, and then it says to create parallel box plots. So you're just going to do like 2 or 3 on top of each other. Okay? Yeah, maybe? Okay, well then the homework is on page 99, number 23 to 26. And I'm here to assist if you need me.